So again, we will go through array, and the most important thing here is going through both searching and sorting an array. Trying to get this out. Okay. So here we're going to talk about single dimension of an array. But our main, again, we already cover an array. We say arrays again, one of the basic data structures. We can store as much items as we want. But one thing is that array is a face size. So it's a static data structure. We have to specify the size, then we put the items. It's not like a list, which is a dynamic implementation, and the size depends on the memory in your computer. So here we're going to go through how to sort an array and also how to search an item in an array. So we start with the searching. Now in this section, we're going to learn two types of searching algorithm. One is called a linear search, and the other one is called the binary search. So now the difference between the two is that with linear search, we have to make sure that our data set, or in this case, the arrays items, is very small. Because what happens is that with linear search, we will start searching the item from beginning, let's say from index 0 to the end. The good news, if the item is the first item, then we are going to do only one comparison. And if it's somewhere around the middle, then we do, so if the size is 50, then we are going to do 25 comparisons. So with the linear search, the best scenario is that the item we are searching for is at the beginning. And the worst scenario is that the item we are searching for is not in the list or is the last item, which means we are going to do a lot of comparisons. Now, the difference between linear search and binary search is the number of comparisons we have to make. So if I'm looking for an item, let's say the item name is key, I will use the key item to compare each of the items in the array to see if I can find it. If I find it, I'm going to return the location where I found it. So we are going to return the index, the location of the item. Now, binary search is good because in binary search, we find the middle value. First of all, if we want to do binary search, we have to make sure that the items in the list or array is already sorted. It's sorted, increasing order from the lowest to the highest. Because what will happen is that we are going to look for the middle value. Then we compare the middle value with the search key. If the middle value match the search key, that's the best scenario, which means we do only one comparison. Now, if the middle value didn't match, that means the middle value can be either greater or less than the search key. Now, if the search key is less, then we are going to forget about the higher part from the middle to the highest. Then we are going to check the lowest. So which means every round, we are going to ignore half of the items in the array. Now with linear search, we have to search all the items from beginning to end. But with binary search, each run, we are going to divide the item in the list half. So if the search key is the middle, fine. If it's not and it's in the upper side, then the half of the lower side, we are going to ignore it. Then we search only the half. The upper side, now we are going to find the middle of the upper side. Then we compare again. So binary search is very good for large data sets because each run, half of the items are going to be ignored or removed. So we don't have to do as much comparison compared to linear. So this is the code for linear search. As we said, the linear search means we search from the beginning to the end. So here we have our method named linear search. And here we are using array. So the argument here will be the array where the items are again stored. Then the search key. Now we are going to use a for loop to go through the items. we know array, the index will start from 0 and it to go up to list dot length less than list dot length. Why? Because if let's say the array size is 10, then we go from 0 to 9. Now, if I have 10 items in an array and I use the length method or write list dot length, the answer will be 10, but the index will be 0 to 9. So that's why our for loop here we say start from 0, the index, and the condition is when I is less than list dot length, then we can go through. But when the item is equal to list dot length, we stop, because if I have 10 items, the index can't go up to 10, it will go up to 9. Then each time we use the for loop, we are going to compare the key with the item. So first we are going to compare the key with 0, the first item. If it's not it, we increment the counter by 1. Then we compare the key with the index 1, index 2, all the way. Now, if the item is index 3, then we are going to return I is 3. So we return the position where the item is. Now, if we go through all the items in the list, we know that index, there's no negative value. So we're going to return -1, which will tell us that again, the key is not inside, or whatever we are searching is not inside the array. Now, the good news is that the implementation of linear search is very easy, because you start from beginning to the end and use the key to compare each item. Now, the next one, which is so this is the animation. Let's go through this. So a linear search animation, our search key is 3. So what we do with the for loop, we compare 3 with the first item. Now you can see that in linear search, we don't need to sort it. We don't sort, because again, we are going to search from beginning to the end. Anywhere we see our key, we stop, and then we return the location. So we compare 3 with 6, we compare 3 with 4, 3 with 1, 3 with 9 using loop, 3 with 7, 3 with 3. Okay, this is it. So in this case, we are going to return 0, 1, 2, 3, 4, 5. The item is in the index number 5. And this is the code again. So I from 0 to I is less than list dot length. Again, if the items is 50, we go from 0 to 49. Then compare if the key equal to the list from 0. Anywhere we reach, if this condition is true, we are going to return the index position, which is I. Otherwise, if we went through all the items and we didn't find the key, then we will return -1, which means the item, the search key, which is the item, is not in the array. Now let's go through binary search. As we said earlier, one of the main conditions of binary search is to sort the items, because we have to find the middle. Now let's say the middle is 50. My search key is 70. So when I find the middle value, I will compare with the search key. No, the search key 70 is greater than 50. So I'll go to the upper side. So all the items from 2 to 50 will be ignored. Then we move to the upper side. Then upper side, we have to repeat the same process again. What is the middle value? 66. Is 66 greater or is the same or lesser than 70? Let's say 70 is our search. You know it's greater. Okay, if it's greater, then all the items below 66 will be ignored. Then we go the upper side again. Now this time the middle value is 70 and our search key is 70. Okay, then we return the position. Let's say this position is 29, 20. We return the position. So you can see binary search, we can search the items very quick. So binary search is good for large items, whereas linear search is good for, again, list with few items or array with few items. So that's the algorithm. Say we should consider the following three cases. If the key is less than the middle element, you only need to search the key in the first half. Because what? The key is less than the middle, so I have to go to the lower side of the middle. Now, if the key is equal to the middle, then we are lucky. Just return, we end the search. Or if the key is greater than the middle, then we are going to search the second half or the upper side from the middle. So those are the conditions here, three normal cases we can get. So this is the animation for it. Let's say we have a list, 1, 2, 3. We consider these lists are sorted. Again, that is the precondition of binary search. The items have to be sorted first. Again, with linear search, we don't need to. You can sort it, but there's no need because you still have to start searching from beginning to the end. So linear search, we don't need to sort. But binary search, we need because we know all the values are in order. So here, for example, we compare our search key 8 with 4. No, 8 is greater than 4. So we are going to ignore the 1, 2, 3 items. So this is what will happen. 1, 2, 3, 4, they are gone. We ignore them. Then we'll come here and look for the middle value. Now, here we have only 4 values. So middle value can be 7 or 8. Now it's up to the operating system to decide, randomly decide what to use. It can use 7, it can use 8. Here we decided, we assume it used 7. So we compare 7 with 8. Oh, still 8 is greater. So we have to go the upper side. So now it left with only 8, 9. We have 8, 9. Now we compare 8, we say 2 items. We still have to get the middle value. So the middle value by random is 8. So we compare 8 with 8. Okay, we got the location, we return it. So let's look the code. So actually, let's look at this diagram first. So for example, here we have a list of items. We can see that the items are sorted and their position are given at the top, the indices. So first thing we are looking for 11. Our key is 11, the search key. So since the items are sorted, we can see here we have 12. This is from 0 to 12, so 13 items. But if we still have even number, let's say 10 items, the computer may decide which one to take as the middle value. So this is very straightforward. The middle value was 6, and in the 6, the value is 50. So we compare 50 with our search key. No, 50 is too big. So we will go to the lower side, and we start from 45 to 2 or 2 to 45. Since 11 is less than 50, we are going to use values that are less than 50, so from 2 to 45. Then we go through the process again. We find the middle value. This time the middle value is 2. We compare 2 with 11. No, this time our key is bigger than, the key is 7. 2 is our index. The key is 7, but still again, our 7 is less than 11. So we have to go the upper side after 7. So it will be 10, 11, 45, which is 3, 4, 5 right here. Now we find the middle value to be 11. Then we compare the 11. They don't have it here. Okay, so let's do it. So we compare the 11 with 11. Okay, so that's correct. So in this case, it means our search key is in index number 4. So we return the index number 4, which is our search key location. This is another example for key 54. Randomly, again, precondition, all the item in the list has been sorted. So we find the middle value is in position 6, the item is 50. Is 50 greater than 54? No. Okay. So we are going to keep items from a value that is greater than 54, which will be from 59. Then this also we find the middle. Let's say the middle is 66, which is 9. Is 66 greater than 54? No. So we go to the lower side. It's left with only 50 and 60. So 59 and 60. So we have 59 and 60, which is position 7 and 8. Then now we compare, let's say randomly we select 59 as the middle value. We compare 59 to 54 is less, but less, there's no any value no more. So which means the search key is not in the list or it's not in the array. Now let's look at the code. So this is the code here. Here we name the function binary search. It takes argument of the array and also the search key. Now we know int low equal to 1 means the lowest index. We know the lowest index in an array is 0. And the highest index will be the length minus 1. So list.length minus 1. Why we say list.length? Because when we look at the argument, the place where we have our items, which is the array, the name is list. So it's list.length minus 1. So if the index have 10 items, the index will reach 9. So now we have the lower index position and the highest index position. And now we say while high is greater than or equal to low, this means we have sorted the items in the array and we are starting again from beginning. And then next thing we said, okay, if high is greater than or equal to low, that means we have item in the list, because index low, if we don't have no item in the list, then high will equal to low, which is 0, 0, or no, nothing. But if at least we have 1 or 2 items, then always high will be greater than, or if high equal to low, it means we have only 1 item in the array. But if high is greater than low, it means we have at least 2 items. So, okay, if that's the case, at least we have 2 or more items, or even 1 item, we can find the middle. So the middle will be low plus I divided by 2. This is to get the index. So let's say there's 1 item and high equal to low, what will happen? It will be 1 plus 1, then divided by 2. So it will give us 1. So the middle will get only 1 item. So if we have 1 item, then the middle will be that 1 item. So after we get the middle, we are going to compare now if the search key we are looking for is less than the middle or greater than the middle. Now, if it's less than the middle, the search key value is lower. So we have to go to the lower side. To go to the lower side, we have to say mid minus 1, because if the middle is index 9, then it will be from index 8 down, because the lower side will be index 8 down. If again the middle is 9, the highest value will be on the right side, which will be mid plus 1. So that's what we have, mid plus 1. So that's the algorithm is right here. We are using while loop to go through the item in the array. The condition, this is more or less like a sentinel value. The condition is that if I is not greater than, or is not greater than or equal to 0, it means there's again nothing. So the while loop won't go through anything. But if at least it's high equal to low, it means we have at least 1 item. So we find the middle value. The middle value will be the first item still. And then we return that as a middle. So mid minus 1 means we're going to the lower side. This is our index. Mid is the index, middle index. So if it's minus 1, we go to the lower side of the index. If it's plus 1, we go to the higher. So how do we go to the higher? Because here we said, okay, if the key is less than the list mid, then let's go to the lower side and check. If this condition is false, then we also check if the key equal to the middle. If the key equal to the middle, that means we have get a search key in the middle. So we return the middle. It means what we are looking for is the middle. If it's not in the lower side and it's not the middle value, then it should be on the higher side. So we'll go through all this. Then if we cannot go no more, it means the item is not in the list, then we are going to return -1, that the item is not in the list. -1 minus no. Wait for a few seconds if it's okay. Okay. So here they again giving us example how the whole process works. Next is how to sort items in array. Now with sorting algorithm, we have so many of them, and you may take that, I think, in data structure class. For example, we have bubble sorting, radius sorting, heap sort. Here we are going to talk about selection sort and also insertion sort. We have so many of them. What is the difference between all these sorting algorithms? It's, again, the ones that execute very fast, maybe they do less comparisons. If you have less comparison algorithm, which means it's going to sort very quick. In computer science, when we are solving a problem, we want a solution that will be faster. Why computer is so famous? Because they can solve problems very, very fast comparing to human beings. So still, when we are designing any type of algorithm, our goal is to design it in a way that it will work more efficient, especially the performance, etc. There are other characteristics we have to consider. This is programming class, so we will not go in detail. Now in software engineering, if I'm designing a software to, let's say, a banking industry, well, fastness is important, but also security is very, very important. So I may consider the security before even the performance, which is how fast it is. Also, if you use less memory, etc. Now, if I'm designing a software for, let's say, a church or non-governmental, I would say, non-profit organization, they are doing charity services. They don't deal with money, any security, data, or anything. Then in this case, I don't care about the security. Like in the banking industry, it's about money. I care about the security. So non-profit organization, then I'm going to forget about security, concentrate on which algorithm or what kind of program can perform more quicker, faster. So that's the whole idea here. So let's see the first one, selection sort. So this is how actually that's why it's called selection sort, to select. So selection sort normally will sort an item in the list. First of all, we have a list of items here. Look, the first time you are going to look for the lowest item, then you put it in the front, you do the swapping. So in selection sort, what we do is that if we get the correct item, we swap it to be in the right positions. So the first, we went through the items, we found out 1 is the lowest. So we swap 1 with the first item. We are not going to touch 1 no more. We start from 9. Look for the lowest is 2. We swap again. So that's why it's called selection sort. We select the correct value and put it in the right position. And that's what we will do throughout until everything is sorted. What is sorted? So every round you will see that we are going to do less 1 item. So for example, here we have, let's see, I think 7 items. Next, we're going to only sort 6 items. Next, only 5, 4, 3, 2, 1. And when we reach the last one, it means all the items are sorted. Now, let's see how the code works. So this is the whole idea of the code. The code is 2 sections. So for example, the first code here, we can see the name of the function, current min. So this will find the min, like here, we say the list. First thing we do, we find the minimum value. Then we swap it to the beginning. Then we find the next minimum, swipe to the next beginning. So we have the current mean, and this is what is going to find the minimum value. So we have a loop to start from I plus 1 to the end of the, here we are using an array, so to the end of the array. Each round we are going to increment. Now we say the first item in the, always we consider the first item will be the minimum. So that's why we have list I. So list 0 is the first item, that is the minimum. Then we use the loop to go through the rest. We are going to compare the next item with the next minimum. We go through till the end of the index. Index will be less than list.length, which means if the size is 20, we'll go up to 19. And here we say, okay, if the current is greater than the list j, then we assign list j to the current mean. So what this section of code will do is to find the minimum value for us. Then later we are going to swap it. So we can see the swap at the top. Swap the smallest with the current list I that you get if you have it. So I think that will be the end. And actually this is the main, this is the whole program here. So we can see the program name again, selection sort. It takes the argument of the array where the items is. We start from the beginning to the end. List.length will take us, if the size is 20, we go up to 0 to 19. Now in this for loop, we are going to find the minimum in the list. So we assign the first item in the list as the current minimum. Then we assign I, the position again, as the current mean index, the index. Then here we also have for j equal to I plus 1. This will take us to the next item. We assign the first item as the minimum. Then we go to the second item. And we compare the second item with the minimum. Sorry. We compare again the second item, third item, all the way to the end. If we didn't find, but always if we have a list of items, there will be one minimum. So wherever the minimum is, again, we assign. After we go through, we have to swipe. From the diagram, we go through, we get the minimum, then we swap it to the right position. And the swiping section is here. So if the current mean index is not equal to I, then we have list I assigned to the list current mean index. Then the current mean will be assigned to the list I. So again, in selection sort, we select the lowest item first, then we swap it to the correct position, select the next lowest, swap it to the current position. So always it's going to be reduced by 1. So here also in a array list also come with a sorting method. So here we say since sorting is frequently used in programming, Java also provide several overloaded sort method for sorting an array. So we know array list is a class. So you have its own sorting method and also other method. So we can sort, for example, for different data types such as int, double, char, short, long, and float using the java.util.array class. So this is, I have an array, the name is numbers with some items. The items are in decimal places. I can use the array.sort. And array sorting method is inside the package java.util or the utility package. So here we can either write import java.util.asterisk to import everything, or we can only import the arrays.arrays. Or inside the code, That's when we're going to call java.util, then .array, then .sort. And this will sort all the items here. Since the argument is numbers, it will sort the content of numbers. We also have para sorting. Okay, so I'm going to end the lectures here. The main goal here is for us to see the difference between binary search, linear search, and also selection sorting. I think there's one more sorting, insertion sort. Oh, okay, it's not in these slides, but our textbook also covered the insertion sort. Okay, so if no question, then we're going to end somewhere here. Or we may see if we need to go through chapter 13. As we said again, chapter 13, most of the questions also will be theory questions. Let's see if we can get it. So in chapter 13, talking about the Java collections. Normally, collections would be an object that carries or store other objects. So we talk about lists, stack, queues, and also priority queue. Here we need to understand the definition. So for example, what is a data structure? A data structure is normally show us how data is organized in our program. And we have different types of data structure. For example, I can organize my data in my program and it will be in the form of last in, first out, or first in, first out, etc. So here we say a data structure is a collection of data organized in fashion. The structure not only stores data, but also it supports the operations for accessing and manipulating the data. So for example, for stack, the data structure is last in, first out. We can do an operation like push to put more items in the stack, or to pop to remove items from the stack. So these are all the different types of Java collections in Java programming. We start with the name collection. We have set, list, queue, and also sorted set. And we should have tree. So in this section, so on the list section is what we are going to call the linear data structure, which means data are stored in sequential order, such as stack queue, the most common linear data structure. Then non-linear data structure can be like trees and also graphs. And we have different types of trees and also at least 2 types of graphs also. So we should understand the concept of a list. Then we should know array list and linked list. The difference between the two is that array list, we have to specify the size. So it's a static data structure. Linked list is dynamic. We don't have to show the size. Memory will be allocated while the program is running. In array list, during the running, the size cannot change. We can allocate anything. So I think we are going to end somewhere here. Our course textbook slides is better because these slides normally focus a lot on the program, the coding. Again, this chapter, we are going to focus more on the theory. So you should know the difference between stack, queue, their operations. For example, stack is LIFO, last in, first out. Queue is first in, first out. With queue, I can insert, I can remove an item, I can check how many items I have. Excuse me. Now, if I'm doing a re-implementation of queue, I can also check if there's a space or if the queue is empty. For example, if I want to remove item from a queue, I need to check if the queue is empty. Or if I want to insert an item into a queue, I have to check if it's full. This is if I'm using array implementation. We also have vector class. Our data is organized with that. And also the operations. Stack class, we can see the operations here. The stack is the constructor. We can check if stack is empty. We can pick. Pick means I want to know what is on top of the stack. Pop means I want to remove an item in the stack. Push means I want to push an item. Pop will pop one item at a time. Push also the same thing. It will push an item into a stack. So if I want to put 3 items into a stack, I'll call the push 3 times. Then we also have the queue and priority queue. We didn't talk much about algorithms, so we're going to skip this section, and we don't need to go detail about the this is again, this slice is for data structure class, so kind of go more details on it. So that will be the end of the lectures for today. We are going to close a little bit early, unless if any of us have a question before we leave. Again, as we said, the final exams will be next week, Tuesday, December 20, from 12 o'clock to 2 p.m. 12 o'clock to 2 p.m. The questions will be 40 questions. Most of the questions, again, will be multiple choice. We have the questions. I think I'll close it. Okay, I'll close it maybe. So again, the questions most of it's right here. So most of the questions will be multiple choice, I can tell. At least 20 to 30 of the questions will be multiple choice. Then we have some few true false questions and filling. The explain the code output, or if there's any error, it's part of the multiple choice question. So they will give you options of different types of error or different types of output, and you have to pick one. Okay, so if no question, I'm going to stop the recording now, and I'm 100% surely going to post this recording in the class because we have a low attendance. And I'm going to
Professor, just to confirm, the exam is going to be on Tuesday from 12 to 2 online.
Yeah, the exams will be online. It will be online on Tuesday, December 20.
Okay, thank you.
Okay. Any other question before we leave? Okay, so if no question, then again, this Thursday is a reading day, so we don't have no class. Today is our final day. As we said again, just to repeat it here one more time to recap. And the final exams will be on Thursday, December 20, from 12 noon to 2 p.m. It will cover chapter 7 to 13, excluding 11. We are going to have 40 questions. Somewhere around 25 questions is multiple choice. 10 questions is true, false. Then 5 questions is filling. Most filling questions will be definitions. So we should understand in detail the object-oriented programming, from what is class, what class consists of, the instant variables, the methods. Then we'll move to inheritance, understand the concept of polymorphism, what is method overloading, and also method overriding. And all this is, I think, is chapter 11. And also from there, we move on to recursion. So we should understand recursive statement and the base case, how recursive functions work. What again? And also Java collection, stack queue, priority queue, lists, trees, graphs. Again, all this will be the theory. We are not writing or coding here. And you will see these materials more in data structure and algorithm class. I think it's 285 or 280 class, CS 280 or 285. Okay, so if no question, I'm going to stop the recording now. And whichever